Let's go over the residual LSTM implementation in PyTorch. We will build on what we already know from the standard LSTM. Torch.nn.lstm module is the most common class we use in PyTorch for building LSTM layers. It applies a multi-layer LSTM neural network to our input sequence. The next class we implement is for building a single residual LSTM layer. The forward method of the multi-layer class would call the single layer class and pass the outputs from one layer as inputs to the next layer. Finally, we implement the single cell class. The forward method in the single layer class would call the single cell class and take the output hidden and cell states from one time step as inputs to the next time step. The only significant code change to the standard LSTM is in the single cell class. Let's look at the Python code now. As with the standard LSTM, the input gate, forget gate, and output gate are calculated based on the input and states from the prior time step, and the cell state is updated to drop the old info and add new info based on the new input. The place where residual LSTM deviates from the standard LSTM is in calculating the output. In addition to the filtered cell state, the input from the lower layer is added before multiplying with the output gate. These residual connections provide spatial shortcut path from lower layers for the gradients to flow more effectively in training deep LSTM layers.